Welcome back, ladies and gentlemen. I hope you enjoyed your winter break. I should be returning to you on Monday, January 6th, but in the meantime, we need to keep moving forward. We're now starting a new unit on polynomials, and a polynomial needs to be defined before we can use it. A polynomial is any expression that consists of multiple terms. Examples would be like negative 6x or 2x squared, or even just 7. These are all multiple terms. When you write something in standard form, it must be written in alphabetical order with the highest exponent first. Example would be if we had, let's say, x to the third y squared. You see it's in alphabetical order. Plus x squared y plus x y, maybe minus y. You could even do plus 5 because constants would come after. So anytime you put a polynomial, you need to arrange it. You need to arrange it so that it's in alphabetical order, x before y, and highest exponent first, so the x to the third came first. Okay, write each polynomial in standard form. So here, we're going to put the 2x squared first, plus 3x plus 1. If you notice, the exponent of x squared is 2, the exponent of x is 1, and if you recall the zero power rule, anything to the 0 power is 1. So really you're saying x squared, x to the first, and x to the 0. But when x to the 0 is 1, 1 times 1 is 1. If you didn't understand that, that's okay. 7k to the third plus k squared minus k plus 64. So you can go ahead and do the rest of these on your own. Go ahead and pause the video and complete this section. Okay, so a degree refers to the number that is in the exponent. So if you're dealing with x squared, you're saying it's to the second degree. And each of these have special names. So as we classify polynomials, we classify them by their degree and their number of terms. If something has a degree of 0, it is a constant. Because remember, I told you if x has an exponent of 0, it's just itself. So it's just the constant. If it has a degree of 1, it's linear. Think about all linear equations have an exponent of 1 on the x. 2, if we see an x squared, we immediately know it's a quadratic. Yep. 3 is a cubic. 4 is a quartic. Yes, it can go higher than that, but this is as far as you'll see with us. 1, if it has one term, it's a monomial. Mono means one. Monophone, monopoly, think of the root word mono. Binomial, bi means there's 2 terms. 3, a trinomial has 3 terms. And then after that, anything 4 and up, we just refer to as a polynomial. So if we look at the examples down below, number 7, it has 6. So how would we classify this? Well, its degree is that it's a constant, and there's only one term, so it's a monomial. Let's take a look at 11. 11 has a cube in the exponent, so this is definitely cubic, and it's made up of 1, 2 terms, so therefore it's binomial. Okay, you pause the video and complete the rest of these. Now here's where the fun part begins. So we can add and subtract polynomials through the use of combining like terms. So if I have a stapler and I have a tape dispenser, I don't say I have 2 staplers. I have 1 stapler and 1 tape dispenser. So here in this first addition example, I have a 2x squared. It means I have a quantity 2 of the term x squared. I also have a minus 1x squared. So what I really have is just 1x squared, because 2x squared minus x squared is simply x squared. Next, I have the term 11x, and I have a negative 5x. These cannot be combined with the x squares. These are linear terms. So 11x minus 5x is plus 6x. Last but never least, our little constants. I have a plus 13 and a negative 23. Therefore, I'm in debt 10. Hopefully that helps. Let's take a look at the subtraction example. This is very similar to the addition example with one slight caveat. You have to begin seeing this as minus 1. You're going to distribute a negative 1 to each of these terms. You're distributing the negative sign to each term inside. That's where people usually get mixed up, make mistakes. So now, I'm going to rewrite these expressions for x squared plus 5x minus 7x minus 3x squared minus 1. Now I can combine like terms and write my full expression in standard form. The x squareds come first. If I have 4 x squares minus 3 x squares, I have 1 x squared. I have 5 x's minus 7 x's. I actually owe 2 x's. And then I have a minus 1. This is my finished subtracted polynomial. Okay, if you go on down and take a look at the problems below, I want you to do all of these examples. I will have the answer key in Schoology for you to check your answers when you're finished.